Hello,
Hello.
everyone. Welcome to the first webinar from the series of webinars that we are planning to hold here called Mid-Rise Building Solutions. My name is Payam Nur Salehi, and we're happy to have you guys here. We're going to go through a very quick introduction. Like I said, I'm the founder of midrise.ca. I'm a construction manager, and I also host a podcast called Real Estate Development Insights. And I'm going to turn it to Slobodan to introduce himself.
Yes, hi Pam. Thank you very much for having me on your podcast today. My name is Slobodan Kukic. I'm a vice president of business development and sales for Canam Group, specifically for Hambro multi-residential division of Canam. I've been with Canam for over 25 years now, and I'm excited to talk to you about today about multi-residential building solutions, especially Hambro.
Perfect. Thank you very much. We obviously appreciate you being here, and for our audience, so thank you for joining us. This is our first time doing this, so bear with us if you see any errors or omissions, ENOs. Uh, we founded Midrise.ca a few years ago with the mission to empower entrepreneurs and small real estate developers with resources to build mid-rise buildings. We think if we are standing it, we're going to stand a chance against the housing crisis in Toronto, in GTA, in Canada as a whole. We need a whole bunch of new people to enter the real estate development market to build these types of mid-rise buildings. And that was our mission when we started out providing content, podcasts, and the webinars, and then this the first of them to the audience, and hopefully you find them useful. If you have any ideas, we're always more than happy to share ideas, collaborate, and hear about them. In this particular episode or webinar, we're going to go through a Canam system and Hambro. Slobodan is going to be doing most of the talking. But before we go to his presentation, just to give him a little bit of background in terms of who we have in the audience and what you guys would be looking for, I'm going to share a poll in the chat there, which would be great if you can answer to what's your professional background? Are you a real estate developer? Are you an architect? Are you an engineer or construction professional? You could be working in the field, and maybe I missed some category and would like to hear about that. I see some answers coming in. We'll give it a minute. Seems so far we have mostly engineers and consultants. Okay, perfect. So Slobodan, I think that gives you an idea who we have in the audience, and you can probably try to focus your presentation on that. Hopefully, what we're hoping to achieve in this webinar is that by the end of the webinar, we can answer most of these questions. What is the Hambro system? How does it work with the logistics of the mid-rise building? Because most of the mid-rise buildings tend to happen in the infill settings, in urban settings, and they bring their own logistic challenges. You don't have the entire world for yourself to set up cranes and do a whole bunch of big deliveries or layouts spaces. So it's important to know how this works. We also want to talk about how the system as a whole can affect the duration of construction. How does it help you with the schedule? How does it work with other elements in the building? There's one thing if you have a single product in the building that is it's very good by itself, but it cannot well integrate with other building elements such as the envelope mainly. So Slobodan is going to talk about that. We want to talk about the performance levels, acoustics, fire ratings, and all the other fun stuff that we have to deal with in a building. Number 6 is a very important question from my perspective as a construction manager. Have you done this before? Is there a proven track record? Because there are lots of good ideas out there, lots of R&D happening, but frankly, from experience, it's very hard to get a product out there from a theory and idea stage to something that actually works in the real world. So we'll explore that. We want to ask Slobodan about sustainability. That's definitely one of the things we need to pay more attention to as a whole, as an industry, as a country, as a planet. And last but not least, cost. That's a question on everyone's mind when you talk about real estate development. Does it help my performa upfront through the construction and at the end of the day as an owner or operator of the building? And I know Slobodan has a couple of case studies that he's going to share toward the end. And of course, we're going to talk about tariffs. Unfortunately, we're in a position that we need to talk about tariffs. Today, March 4th, is not a very pleasant day. This is not a political platform. We're not going to get into politics, but I know a whole bunch of people have been asking us, and I'm going to ask Slobodan to address that toward the end of our presentation. So there you go. All yours.
Perfect. Thank you, Pam, and thank you for this introduction. And again, before we continue, I must say that I watched some of your podcasts, previous podcasts, and a guest and caliber of guests that you had before. So I must say that based on all of that, I'm really honored to be here today with you.
Thank you very
So
much.
maybe we can start with introducing Canam, the company that I worked for the last 25 years, and also the company that is behind Hambro structural building system that we will be mostly discussing today. So who's Canam? So Canam is a North American leader in steel construction solutions, specializing in commercial. Sorry, I'm just to change the slides. Commercial, industrial, institutional, multi-residential, and even bridge infrastructure projects. We as a company offer projects, and a lot of people probably are familiar with these, like open web steel joist and steel deck, structural steel, Murox and Equinox building systems for commercial and industrial buildings, as well as Hambro structural building system that fits really in a multi-residential market. As a company, collectively, we do about 10,000 projects a year. And basically, sorry, I keep forgetting to change slides. And I'll show you a few prominent projects that they have completed in last recent years. For example, Champlain Bridge in Montreal, just completed a couple of years ago. Replacement of Tepanzi Bridge in New York. And in the last 60 years, Canam's built over 80 sports facilities across North America, and probably 50 largest stadiums in North America. So I'll just show you some of them on these slides. For example, New York Yankee Stadium in New York, Rogers Arena in Edmonton, BC Place in Vancouver, New York Met Stadium, Jets and Giants, BMO Field in Toronto as well. We did both phases of it. And one of the most complex ones that we ever done is Falcon Stadium in Atlanta. The following slide will show you basically the glimpse of complexity that we've done on that stadium. You can just appreciate the amount of steel and type of complexity that there was from that picture rendering of steel structure that we installed in that stadium.
Pretty impressive. Pretty impressive. Just we don't want to scare people off. These are your big shining diamonds in your portfolio. But
Absolutely.
I know you have a whole bunch of mid-rise projects that you're going to get into.
Absolutely, yes. And just to conclude with this, again, a lot of distribution centers and warehouses, airport hangars, and even fabrication facilities. For example, in Ontario, we've done all the Honda fabrication facilities, a lot of shopping centers and warehouses. But basically, as a company, we have 5,100 employees, offices and manufacturing facilities all across Canada and US, but also offices in India, Romania, Philippines. And just to show you the map of our fabrication facilities, we have 22 plants across North America on the west and east coast, with over 500,000 tons of steel capacity in our facilities. So that's in a nutshell, Canam.
And I'm going to, just before I go to the poll, I'm going to ask you the question I asked you offline. You are a Canadian company. You're owned Canadian, and you identify yourself as a Canadian company, correct?
Absolutely. So Canam started in 1960 in Quebec, in the Beauce region of Quebec, family-owned company, and ever since been always Canadian, proudly owned company.
Perfect. Thank you. So before we go through the rest of the slides, here's a question. Here's a poll that I'm going to put it into the discussion or the chat bot there. As a construction manager, I'm fortunate enough that from time to time I get approached by new providers and new systems and saying, here's a new product we have. Here's what we're trying to do. Here's the R&D idea that we have. And there are multiple things that I go through as a checklist before considering the new system. So I'm interested to know what you guys consider most important when you look at a new system, which potentially has promise. So I can see overall cost is, and I think, yeah, let's give it a minute. Let's see. Okay, we'll give it another minute. And here's the important part. And again, it's good that we're seeing sustainability answers. One of the conversations that we typically have with our clients, and mostly real estate developers, and I want to say newer developers, is that there's a difference between upfront cost of a system and overall cost of a system. There are many systems out there that upfront, standalone, look at them on a piece of paper, quotation, they will save you money. They will be cheaper. But when you try and build it into the whole building, build the construction process, integration with other elements, they end up costing you probably same as your highest bid or even higher. So it's important that we have this in mind, that there's an upfront cost and overall cost. It seems that overall cost and integration with other systems is the choice to go here as well. So we'll go forward with the presentation. There you go.
Okay, so now we can dive in our Hambro division, multi-residential division of Canam. There's a picture of one of the typical projects we've done just recently. But just to kind of, again, put it back into perspective, in a multi-residential segment, people know Hambro very well because we were servicing the market with our product, composite floor system, for the last 60 years. And we always fly Hambro flag, but a lot of people do not understand that the connection between Hambro and Canam. Hambro is a product, and Canam is a company that always has owned Canam in the last 60 years. So, but before we go into the how we do things and what's the way how we do it, I would like to tell you why we do things the way we do it. So we saw project after project, year after year, with a traditional construction delivery method. We saw that projects are always, behind the schedule, and cost overruns. Budget is always blown in the projects. And we see this project after project. So we kind of made this our mission to eliminate these two major pains. So we made it our mantra to say no delays and no cost overruns, and we guaranteed. And in the following slides, I'm going to try to depict how we go about things in order to deliver those promises. So we started.
Those are two very big promises. Sorry to interrupt you, but those are two very big promises. So
I'll show you how we can do them. Yes, and we have a pretty good track record for that. So for us, everything started in the 60s. So Hambro is a composite floor system. So Canam was supplying Hambro composite floor system to the market for over 50 years, and started for us all in 60s, in the early 60s when Hambro was invented. Actually, out of all places in Ottawa, a couple of engineers came up with they wanted to come up with a floor system, like a concrete floor system that can be installed with a simple labor on a block wall application. Because at that time, in 60s, some of the guests probably remember, the multi-residential construction was mainly done with a block wall. So this was kind of a type of system they wanted to come up with, and they came up with this composite joist floors with a concrete topping floor system. Obviously, this evolved over the years, and Hambro today has been used on many different applications, and I'll show you in following slides. But why do we call it a composite floor system? The reason is you can see the top chord on a screen is embedded in a slab for 1.5 inches to create that composite action between steel and concrete. So it's basically, when concrete hardens, it's basically a T-beam section between concrete and steel. That composite section brings us a lot of benefits. I'll just mention a few. Vibration, for example, just being integrated with the concrete slab like that, vibration of composite product compared to the non-composite, let's say joist, is about 3 times on a paper stiffer. So having a better vibration, you're improving your sound properties, and also it gives us benefits when it comes to the fire, and I'll explain that in a few minutes. And we only have a 3 to 4 inch slab above the joist, with no requirement for any rebar, just a wire mesh. So it's a concrete also forming system as well as a concrete slab. And I'll just go into the installation steps. Very easy system to install. We place the joist typically 4'1" on center. Reason for that is because we fit the standard sheets of plywood, the 1/2 inch CDX plywood in between the joist. So basically, joists are 4'1" on center. We use those roll bars, we call them. They clip into the holes in the top cores every 21 inch, and we lay the piece of plywood on top of it. Which acts as basically forming for a concrete, and it's designed to carry the wet weight of a concrete. We have no rebar in the system, only wire mesh. Typically, we use 6 by 6 gauge welded wire mesh, and we don't have any chairs. The reason for that is, if you remember that picture with that top cord being embedded in a slab, at the top cord location, actually top cord acts as a high chair for the joist. So to lift that mesh up exactly where we need it to take care of that negative moment above the joist. And then in between two joists, it's just a one-way slab, 3 to 4 inch thick, and mesh sags naturally down to take care of that bending moment in between those two joists. So that's in a nutshell how it works. And the greatest point of Hambro is that we have no shoring or reshoring. So literally in 24 hours, we come back, we take those roll bars and a plywood, we strip them down, and we reuse them on the next floor. So now in a 24 hours, you have floor below completely free of any obstacles for your MEP, mechanical, electrical, plumbing trades to work below. Any other system that utilizes any kind of a shoring waits, as you know, probably 3-4 floors and 30 days after to even begin that kind of work. So you have a steady flow of work, and those trades immediately can access the floor below, which is a huge cost and time saver. We also have a variation of this system, and this system is really made when we have a structural steel frame only, and you have iron workers in a unionized environments. When you have iron workers doing structural steel, it makes sense not to bring carpenters to do plywood and roll bars. So we came up with a variation of the system to actually install, so that one trade can install everything. So in this case would be iron workers that can install the steel deck instead of a plywood. This system is slightly more expensive because it utilizes stay-in-place form, but all other attributes structurally and architecturally in terms of sound and fire are exactly identical between two systems. We also came up with a variation of this product with a composite girder. So composite girder is basically an element that can carry much more loading than regular Hambro joist. And in conjunction with let's say composite columns, which is really a steel column filled with concrete, we can actually build transfer slabs. And transfer slabs applications typically, like most of our viewers probably know, when you have a garage level below and apartments above, so you require the transfer slab that's typically built with a heavy concrete. Or if you have a mixed-use building with a commercial space on the bottom and an apartment building above, again, you have a wide open commercial space. The loads do not come up in the same way above and below. So you, again, need to have that transfer slab. So we can actually build with this system transfer slabs as well. And again, it's a very simple system, 3 to 4 inches concrete as well, no rebar. Girders and joists and columns obviously take all the loading. So it's much more economical if it's applicable to the situation.
Sorry, Slobodan, I'm going to interrupt you for a second there. If you can go back to the previous slide,
Yes.
one of the things that we typically run into issues with in steel buildings is having to basically wrap all the steel columns. So I'm looking at your column there, which is infilled with concrete. Is it fair to assume that at a certain dimension, you can basically assume that there's no drywall needed around that column?
No, yeah. So by code, you're allowed to, if you fill the concrete compositely with a concrete, that column is, and there's a there's a certain ratios that we need to respect for concrete steel thickness when we design it, but that's automatically fire rated column, so no additional fire rating protection is required on the column.
Right. Okay, perfect. And I see, sorry, I encourage everyone to ask questions as we're going through this. We're going to have a QA session at the very end, but it would be great if you ask questions. So I see a question just came in. What's the best way to deal with penetrations in the slab? Sleeve before you pour concrete, or similar to CIP, or I guess do you core after?
Yeah, so that question, I answer it multiple ways always. Great question, by the way. We because this is just a one-way slab reinforced with wire mesh, you can really do it either way. You can either core it after the fact and there's no restrictions where you can core. Obviously, we just don't want you to hit the joist. But in between the joists, really, there's not much restriction. We just ask 6 inches on each side to be respected. Everything in between, you can core wherever you want. It's a very thin slab. It's not a heavy rebar. You can really easily core. Again, if you want to sleeve it prior, you can do it as well. But in my experience, I find that sleeving always is in the wrong spot for some reason. They never put it in the right space, so they end up coring it. So I say, I recommend either way is whatever works better for you. But you can do it either way.
And if I may add to that answer, is that considering that your joists are about 4 feet apart, you have a pretty good chance of not hitting any of those joists. So you're pretty flexible in doing your coring afterwards. There's the second question that we had just came in, and can you run the ducts, HVAC ducts, in the joist space?
Absolutely, and I will address that in the following slides.
Perfect.
For sure you can.
Keep going.
So, and when it comes to fire rating on entire transfer slab, you can do it in 2 ways. We can do it either with a spray-on application, like you can see here. This is a garage. It's been done with a spray-on, and you can see the columns are just on painted. They're not protected with any other drywall application. Or you can do the drywall membrane sealing below to give you the fire rating. And I'll explain that a little bit further on in the slides, how the fire rating actually works with our Hambro system.
Perfect. Okay, so we're going to do another quick poll here. I guess the question is from the audience, which one of these ones you're more interested in learning about? I'm going to put that in the polls again, so Slobodan can weigh his time accordingly. You want to know more about the fire rating, the acoustics, the construction sequencing, envelope performance, balconies, or shear walls? Okay.
Feels like it's a bit of everything.
It's a little bit of everything, so it kind of lines up. And I just realized that our fifth choice doesn't line up with the poll there, but we'll take it as a case study. So, okay, let's go. Thank you.
Okay, so main attributes and features of Hambro really, and this is why we are fit in a multi-residential construction. Hambro has a very good fire rating properties. We have up to 3-hour rating with just a single layer of drywall. And I'll explain that how it works. We also have a very long spans up to 43 feet with a fairly shallow profiles. I'll give you example. 12-inch joists can go up to 30 feet. 14-inch joists can go up to 35 feet. So basically, in a multi-residential industry where you want to clear, large spans, let's say outside to corridor, 30 to 35 feet, 14-inch joists will suffice in that type of application, which is fairly shallow. And you can fill, like we said, you can put all your mechanical plumbing basically within the plenum of assembly, and that's the whole idea behind it. We have a great acoustical properties, STC of 57. That's a tested STC with just a single layer of drywall with a furring channel directly to the bottom quarter of a joist without any insulation in the system.
Sorry, you said fairing channel, not a resilient channel.
That's the same thing, yeah. Resilient channel, the head track.
Okay.
Head track. So sorry, different ways of calling it, I guess. But yeah, just a 7/8 head track tie wire to the bottom cord of a joist and attaching just a layer of drywall to the furring channel gives us STC basically of 57. Most of the viewers probably know the code requires 50. And if you look at the curve of the STC, 57 is almost double performance of 50. So we have a really excellent sound properties. And the reason is because we have that plenum space between the joist and the drywall. So it's an assembly, and that's why it performs so well. Compared to cast-in-place concrete, that's barely 50 or precast. So we have quite a bit better STC values. IIC is about 30, which is kind of equivalent to any kind of a concrete floor system out there. The whole idea is to put all, like we said earlier, to put all your mechanical between the joist or through the joist. We always have a standard geometry, 45-degree geometry, and we provide actually the table to tell you, for example, in a 12-inch joist, you can put 8-inch round, 9x5 rectangle, and so on and so on. In a layman's terms, in majority of our joist depths, you can fit all of your mechanical through and in between the joists. So you never end up with any bulkheads or suspended ceiling. The whole point is not to have the bulkheads or suspended ceiling. So when you really look at a 8'6" ceiling without any bulkheads versus concrete building that has, bulkheads all over the place and suspended kitchen and bathrooms, 8'6" almost looks better than that. So that's the advantage of this whole system. But just to go back to fire, because that is a very important point, it's an assembly rating. I'll just show you a quick video here how it works. So it's a really assembly from top of the concrete to the bottom of a drywall. The drywall is attached to the head track channel, tie wire to the joist, and we get basically 3 hours with just a single layer of. How do I go back to the slide? Sorry.
Here, I just pulled it
up. We get 3 hours with just a single layer of drywall. The difference between 1, 2, and 3 hours is the amount of unprotected openings you can have per every 100 square feet. So for example, 1 hour rating, you can have up to 16 by 16 hole unprotected with no dampers per 100 square foot ceiling versus 2 hours is 12 by 12. So it scales down a bit. So that's the difference between 1, 2, and 3, but it's always single layer of 1/2-inch type C or 5/8 Ulix drywall that we have. So our assemblies are extensively tested by UL. We have one of the largest tests in a UL, 33 pages of temperature tests in the UL book. It's quite complex test, but we're here to explain and to support and to help people understand it.
Perfect.
Also sound, like I said, STC, we just talked about it. We also lately, there was in the code introduced the flanking noise sound. Pardon me. That needs to be tested, and we did extensive testing really on a different type of supporting systems, and we have all the tests to prove that we meet the minimum requirements of a flanking noise requirements in a code as well.
And just to go back to the acoustic discussion for a second, I guess you're the typical floor assembly that you're seeing on top of your Hambro system, because you already have the concrete as part of your system.
Correct.
You don't typically see a flooding happening of a self-leveling product, a gypcrete product, and
No,
nothing, right?
absolutely
So hypothetically, I can come up and just have the concrete there, and on top of the concrete, roll the rubber mats and put my
yeah. The only
engineer
time
hardwood.
Yeah, the only time you would require some kind of it's to bring that IIC, the impact noise one, when you have a hardwood or tile flooring. Typically, they put some kind of an underlay. Or lately, actually, there is quite a few products, like a Shaw has a very good laminate, like a luxury laminate that has already built-in membrane into it. So it's either a membrane that you put, or you can have it built in a product. But that's the only time you're going to have something. But that's only for impact, hard knocking noise that you have from the heel noise, right? Basically.
Perfect. And I'm just going to take this opportunity. There are questions coming in. So there was one question, I think, when we were talking about the penetrations. Could you do slab depressions in this system, like something for like a shower basis?
Yes, we typically do that. But for that, for example, if it's more than ½ inch, we would thicken the slab as well, because it's fairly thin slab, 3.5 to 4 inch slab. So most of the time we do that, just a small, like a ½ inch to an inch at the most depression for let's say for a shower, like you said before.
Perfect. And I see questions about cost. We're going to get to the cost toward the end of the
Yes.
presentation. And I see another question coming in. Hypothetically, maybe just walk us, as we're going through this, walk us through some of the design mindset that the designers, the engineers, the consultants, the architects need to think when they're thinking about designing a building with your system.
Yes, absolutely. So maybe just to conclude this part here,
Sure.
Hambro really is a versatile floor system. It fits on any bearing surface. For the last 50 years, we used it probably on any type of bearing surface, from steel, light gauge steel, structural steel, concrete walls, ICF, block walls, and even wood walls. Out west, we have some plants utilizing Hambro float joist system with concrete topping on wood walls as well. So it's a very versatile system. When it comes to design, it's a really engineered product that we supply all the technical manuals for outside engineers, let's say, to design it. It's no different than designing standard open web steel joist or TJI joist in wood. You get all the properties, tables. So that's how you would spec the product itself as a joist product, right? I see another question about heating system, in-floor heating. Yes, absolutely. In-floor heating is being done all the time. They basically tie the tubes to the wire mesh. We thicken the slab to minimum 4 inches at that point, because we need some minimum cover on a pipe. But typically we see ½ inch or 7/8 tube tied to the wire mesh. And yes, absolutely.
Perfect. Okay, let's go forward.
So in a downturn, so that's a Hambro as a floor system. Like I said, that's how we started in 60s, and the last 50 years, that's what we were supplying to the market. But in a downturn of economy in 2008 to 2011, market really requested from companies like Canam to come up with a more vertically integrated offer. So we created a complete structural building system for mid-rise buildings that we provide to the market to today. So we started in about 2010, and ever since we built millions of square feet, and I'll show you how it works. So our mid-rise system that we're discussing today is really consisting of a few different elements, but mainly the load-bearing steel stud panelized wall with our Hambro floor system, obviously. As you can see, those load-bearing steel stud walls, they're panelized in our controlled environment in our shops. They can be whatever the floor height is, and with approximately up to 25 feet. As you can see in this picture, we put doors and window opening. They're all already put in the panels. And our base wall product comes with the outside sheeting, obviously, dense glass or any kind of outside sheeting that you put on the, that's a base product that it comes with. Those panels are delivered to the site in a special crates, and we basically, like a Lego, in a sequence of erection. They're stacked in a sequence of erection on the trucks, and we basically erect them as a Lego, basically on a building plate.
Perfect.
However, we have a variation of this offer. We can actually also put in the shop AVB membrane, insulation, Z bars, or even brick ties, whatever depending on the type of a finish that you have for facade system. So that became really with all the lack of labor lately and the lack of trades, this became very plausible option lately for many people. And we have
Sorry, if you go back, can you go back to that slide, please?
Yeah.
So hypothetically, if you're shipping that product to the job site, all we're doing on the site is literally hanging the cladding. Like if it's a
exactly
metal cladding or
windows are pre-treated with the membrane as well. So you just pop in the window and you apply the cladding, whether it's a brick or any kind of a siding. That's what you just do on a job site.
Is there a significant challenge or cost difference shipping an unfinished panel like the one that you were showing the previous slide versus this one?
Not really. It doesn't take much more room on a truck to just deliver a panel like this. I'll maybe let the cat out of the bag. We're working on in R&D to finish the panel fully with even the facade. When we come up with that panel, that might be having a little bit more impact. And we're trying to also have incorporated doors and windows in a panel as well. Again, whether we're going to be able to manage that or not, that's to be seen in the future months. But if it's a fully finished like that, what might have a little bit bigger impact on a shipping. But like this, just insulation, Z bars, AVB, and window treated really does not have much impact at all on shipping.
Perfect. Thank you.
So just to show you, we have a few different membrane, AVB membranes that we offer to the market. So we can offer either dense element, which is a board done by Georgia Pacific that already has AVB built into it. And then all the seams and screw holes are treated with a liquid membrane, as well as all the openings. You can see that all the openings are also pre-treated with a liquid membrane. So you're just ready to pop your window in on a job site. But we also offer fully, 3M or a membrane, like a fully peel and stick membrane as well. We selected, there's a multitude of these barriers available on the market, but we picked two, 3M, also the Suprema. So we found that these two perform really well in any kind of weather conditions. So we kind of decided that those are the two that we will be offering to the market.
So these are going to come there. The panel is going to have the membrane on top. The window obviously is already membered there. And how do you deal with the overlap? Is there a particular detail between the two panels coming together?
Yes. So basically, the board itself, there's a couple of fire tests out there that we use. We always use a fire test that requires only one layer of drywall on the outside. So that way we don't need to have an overlap of a drywall. But where the two panel meet on a job site, and I'll show you in the following pictures, we actually we finished that on a site. Just that little joint between two panels above or on the sides, we finished that on a site. And I'll show you in the following pictures there. But any kind of insulation can be placed on the outside, whether it's a foam insulation or lately we use mostly a rock wool, and then obviously Z bars and brick ties are attached to the panel. Those Z bars and brick ties are also offered to be in a thermally broken Z bars and brick ties, because lately we participate in a lot of net zero projects where this is pretty much a must and a requirement. So that's also an option. And just to show you how that looks like when it arrives on a job site. So you see those gaps in between the panels. We close those on a job site. Basically, we apply the AVB there, and we put a piece of insulation that's missing there. This is, for example, one in a rock wool. You can see it's ready for just the siding to be placed on a job site. So CoreEyes, I'm not sure how many people in our group today heard about CoreEyes. So it's really a product that we came up out of necessity, to be very honest with you. It's a permanent steel forming system for concrete cores for elevator shafts and stairwell shafts that are on every building. So in the past, when we just had a steel structure that go around these concrete cores, we would show up on a job site, and typically the general contractors and or developers, whoever is building the building, would have to put these cores up prior to us coming on site, whether they're from precast or concrete or block. First of all, that would take a long time, and also there's always in these cores, there's always embed plates and connection details that we need to connect our steel structures to. So we found out, first of all, precision of these of concrete work on site is not always the greatest, and we find those embeds are always in the wrong spot. So we are the one ending up fixing them, and there's a lot of finger pointing. So we thought that system like this will actually speed up construction tremendously. It saves weeks of the time because we can actually erect this system at the same time as we erect entire steel structure. I'll just show you the quick video.
And while you're pulling up the video, I have to say that when you and I first met, and we met with your team about a year or so ago, this is the product that I think it's very key for the mid-rise projects, just because of the time it saves on the site. And there are other companies that are coming up with innovative ways of doing this. But yeah, that definitely helps with the schedule.
Sorry, Pam, I don't see this video. This is the wrong one, actually. I don't see this video in a.
Oh, I apologize. Maybe we don't have it there. So we'll send it out afterwards. I apologize for that.
Okay.
That's actually a good video.
So, but basically, as you can see here, that it's a steel forming system that utilizes the same amount of rebar. It's all intents and purposes. It's a concrete wall. We put the same rebar that we would put in a concrete walls. The corners stay open actually for the typical zone steel to be slid inside, and the regular steel rebar that goes horizontal and vertical that goes in a panel. We have actually pre-drilled holes inside of the panel where the rebar is just being slid in without requirement for any tying. So it's a very quick installation of the rebar. So basically, those panels can be erected at the same time as a steel structure around. So basically, it speeds up. It takes us maybe half a day or a day longer just to put these panels up, and then they're poured at the same time as we pour the floor system as well. So this basically cuts tremendous amount of time on a job sites in construction, and we found to be a huge cost saver in terms of time.
So two follow-up questions. One is, and I think I might have asked you this before, you don't have particular limitations in the sizes of these panels, right? So depending on the core size, you can go from an elevator to staircase or combined on a scissor stairs. You can do all
anything,
of them, right?
exactly. They can be just a standalone shear wall concrete. Let's say you need a standalone concrete shear wall. It can be that. It can be elevator shaft. It can be stairwell shaft. And we put stairs and embeds and all the attachments for structure around it in a panel as well. You can see on this picture the embeds are already placed in a.
Yeah, I can see that. And hypothetically, so let's say if you're standing on a deck today, you're going to erect it day 1, day 2, place rebar, day 3, pour concrete, and pretty much you're done.
You're done.
So
Exactly.
you're doing it like a 3-day cycle per floor per core.
Yeah,
If you
exactly.
have multiple crews working, you can probably do more.
But we typically do. Let's say we prepare typically about a week. In a 7 to 10 days, we prepare about 10,000 square feet for pour of the entire floor. So that includes also the core. So it's no different basically than doing the steel structure at the same time. So we add just a little bit of time to the steel structure, not much compared to what it adds when you build them by themselves.
Yeah, and these are like from a capacity perspective, these are no different than your typical casting. Like they will give you the same shear, they will give you the same lateral support and load
same amount of rebar, same lateral support, same shear elements. So it's a really stay in place permanent forms, and we get a fire rating from the concrete, so it's automatically fire rated. So you don't need to do any drywall or anything on it. You can leave it exposed, and we can see that on us following slides. So this is just to kind of give you the example. We did a case study on a project in Edmonton, 4-story, 100,000 square foot building. For us to do this, including core rise, is 11 weeks. They just needed, if you look at the schedule, if they had to do cores prior to us coming to the site, it would take them just 8 weeks to erect the 3 cores. They had the 2 elevator 1 elevator and 2 stairwell shafts in each end. You can see in this picture. So
I can attest that even from other projects that I'm working on, it's always a big deal. Like if you can get a
it's a
core
big,
ahead of time. Yeah.
and precision is incredible, not even comparable to compared to the traditionally built concrete cores. So and that was the reason, and cost is about the same. So at the end of the
Mhm.
day, it's a really a cost. It's not cost saver is in a time, not really in a product itself.
This goes back to our original conversation at the beginning that it's more of an overall cost item. Like you're
Exactly.
saving, you're using a premium, you're getting a premium product, but at the end of the day, you're also saving overall cost on the project.
Yes, and we wanted to have a full control over the structure. So once the foundation is completed, we get on and we don't have any other trades in a way. So we're the only trade on site. That way you can control entire construction schedule by yourself rather than having a pointing fingers with the other trades. And just to kind of show you how they look like when they're finished. So this is the deck that can be, you can leave them exposed, or you can just laminate it with a drywall. Like this is one project in Ottawa, for example, we did just recently. So it's either or. It's depending on what liking is to the architect or the owner of the project. Also balcony systems. So we have a very type of balcony systems that we utilize in our structure. All our balcony systems are thermally broken. So you have a full thermal break between outside and inside. They can be cantilevered or they can be balconies on columns. We utilize a precast slabs actually for those. So they're erected after the structure is all fully erected because they're not connected to the main concrete slabs inside. And just to show you that picture, so you can see that inside and outside slab is fully thermally broken by the structure on the outside wall. And you can see this is a cantilevered slab out. There's a beam, actually cantilevered beam, galvanized beam that goes from inside out to the sleeve in the wall. That's the only steel piece that goes from inside out. But then we insulate that piece from the inside of the building in order to get that full thermal break.
And sorry, if you can go back to that slide, and I found the clip from the core rise, I'll put it on the screen in a second. But I think for those of our audience who are involved in developing projects, balconies are one of the trickiest things to get right the minute you step away from CIP. Like when we do CIP, there's a way of doing it. It's not perfect. You get thermal breaks, thermal bridges basically, and you lose a lot of efficiency around the windows on the window wall systems. And frankly, I have to admit that for the past 3 or 4 years, I've been looking for a solution on balconies. There are a couple out there. I don't want to name other companies right now, but so far they've been very expensive. So I'm personally very excited. If I haven't, you and I haven't worked on a project, I haven't seen this in action, but if this works, this would be a really good substitute. And I'm gonna try and steal the screen for a second
Yeah,
because I found a clip for the core rise. So this is the animation that you were looking for.
yes. So basically panels are just erected like any other panel. The zone steel is slid in on the corners. The corners are open, and we just close them with the steel plates at the end after the rebar is inspected, obviously. And all the vertical and horizontals have pre-drilled holes already in the panel. Those are the plates that close the corners after inspection. And basically we put a rest of the steel structure around it. Our joist, actually the panel is designed to carry the joist in non-composite stage as well before the concrete's poured. And when we pour the slabs, we pour the cores at the same time.
And it becomes one with the slab itself.
Correct. And we repeat floor to floor. So it's a platform construction, and we repeat it every floor.
Perfect. I'm going to pull back the slides. There you go.
So yeah, that's a balcony solution. Like I said, they can be either on a columns or they can be on a cantilevered. And this is just a slide to show you the sequencing of entire construction. So basically, we show up on a site when foundation is ready. We stand up our core rise, like you explained earlier, Pam. Our walls are put in place, joist, mesh. Everything's ready for concrete pour, and we pour the slab. It's just a 3.5 to 4 inch slab. And again, coring can be done prior, meaning the sleeving prior or coring after, and sequencing just repeats. Our typical schedules, depending on the complexity of a job, is between 8 to 10,000 square feet per week and a half. Typically, that's what we uh, utilize for speed of construction. Again, that depends on a complexity of a project, but some are faster, some are a bit slower, but typically week and a half for about 10,000 square feet.
And you and I have talked about this before. Let's say of the mid-rise buildings of the like between the 4 stories all the way to let's say 10, 12 stories. What's your sweet spot when it comes to height? Is there a limitation to using like the core rise or other elements?
So not really. This particular mid-rise system can go up to 12 stories. That's the maximum we've done, because steel stud at some point get really heavy, on the bottom floor. So that's the highest one we've done. So it works really well. And then after 12 story, that kind of becomes almost a high-rise type of building. So there's other elements, other building systems that work probably more economic. So
So 12 is probably pushing it, but you like somewhere in the area of 10, 8 to 10 is probably your sweet spot then.
yeah, absolutely. Most of our structures are between 8 and 12 stories. Yes.
Perfect.
This next slide is really kind of to show you how we approach the design of these buildings, meaning in terms of where we place the load-bearing elements. We really like to go long spans between outside and corridor walls, where you can span that whole space, like you see in that left picture there. Now all your walls inside are completely non-load-bearing walls, and you can even do the retrofit down the road much simpler and easier because they're non-load-bearing walls. And then in the corridor, we have only a mini, what we call a mini joist, which is just the top chord of a joist that can span up to 8.5 feet. So basically gives you all that room to put all that mechanical that typically goes in a corridor space there.
Yeah. And sorry, just in the interest of time, because I know we promised until 1 o'clock, we will stick around longer for questions and answers for those of our audience who are going to stick around. But just to make sure we get to some of the key points, I think I want to bring it up that we want to talk about the tariffs, we want to talk about the cost, and any other items that you have. So
let's speed up a bit. Yes.
Yes.
So basically, this is our typical layout. Like I said, outside to corridor, that proved time and time to be one of the longer span you have, the less bearing elements below you have, and hence the more economical structure. And obviously, cores are typically done in our core rise system. But this is not to say that that everything has to be square box. The complexity of projects can be can vary. Buildings can jog like this, like you see in this slide here. But what's important part when it comes to designing these mid-rise buildings is a vertical alignment. This is really where economicity comes in. So we're really looking, when we approach the design of these buildings, is when we work with the architects and designers, that buildings, it can jog. We don't care about that. That does not change significantly the cost. It's really a vertical alignment. The less of these misaligned points that you have that create transfer points, the cheaper the building. Not to say that we cannot do them, it's just that the most economical building is the one that stacks all the way through. And this is just to show you a few different type of layouts that we do. We also have something that we call hybrid. I'll go quickly through it. Sometimes when you have a complete garage, let's say below building, and then you have multi-residential units above, we actually tend sometimes to propose to have columns from a garage, let's say, be aligned throughout the building, all the way up the building. So that way, and then still keep the outside wall to be a load-bearing walls. So that way you enclose your building as well at the same rate as a normal design with the inside walls. But instead of having inside load-bearing panels, we can have just the 2 lines of structural steel that the columns align all the way to the garage down. That way we completely avoid a transfer slabs below, between the garage and the spaces above. So that's kind of a variation of the system that we can utilize in certain designs. Just to kind of show you how that looks like. We also do in a lot of, there's a video about the BIM, but I'm going to skip that in the interest of time. We do also through our design process, we try to clash all the mechanical, electrical, and designs together with the structure in order to avoid any kind of conflicts on site. So that's part of our pre-construction services as well. So again, this whole approach, how we approach our design of these buildings is mimicking the design build approach in an industry. And so how it works, you really try to get involved in the early stages. So early stages, I like to call it napkin sketch. So when owner and an architect sit down and they say, okay, we want to build this type of a building, and they have a very basic layouts of that building. So what we do, basically, we get involved at that stage when the drawings are 5 to 10%. We take those drawings, we provide the know-how and value engineering at that point, and we say, hey, to build our system, this you can do it this way, the most economical way. And we are able at those early stages to provide a budget certainty and schedule certainty. As long as you don't change the building from that point on significantly, we can guarantee that. And that's why we can guarantee that early price and a schedule. We also offer ER services. So I don't want engineers on a call to panic. That doesn't mean that we do engineering record services. We offer them to be under us, so for ease of construction. So what we do, we pair up with the local engineering community. We work with a multitude of engineering companies throughout Ontario and Canada. In every municipality, we have somebody that we work with, or if owner or developer or architect has an engineer that they like to work with, we can pair up with them. So they would help us with the concrete elements, because we're not a concrete engineers, we're really specialists in steel, and we would optimize and design the steel structure above. So we do it together under one umbrella, so that helps basically that whole coordination process. And you can control the design that way. And who controls the design controls the cost. So this is the way how we approach this, and this is why we can say that we can guarantee you the schedule and the price, because we can control the design from very end to all the way to execution as well of the project on site. Also, we have a fully experienced crews that go on all our job sites, erect our projects with our own basically site supervision and our own project management, obviously, on every job site. And this is just kind of depict that whole process. So in a traditional ways, as most of the people on a call probably know, owners, developers, and architects, they first design some building. They typically in the traditional ways, then they go for tender for GC, then they go for tender to trades, and time over we hear it's over budget, it's over schedule, and so on and so on. What we're trying to do, let's get involved at those napkin sketches where we can actually influence design, show our know-how, and provide you with that early stage budgeting and actually schedule certainties, so you can make a decision based on those tangent deliverables. So just to show a couple of typical projects, we do a lot of condos and apartments, senior care facilities. We do tremendous amount of senior throughout Canada, hotels, condos as well. And this is the largest one. Like I said, 12 stories, the largest one we've done so far. But again, we have a full list of a portfolio of projects throughout Ontario and every province that we can show. We've done millions of square feet in the last few years throughout Canada and US as well.
And we'll share that list with the slides through the email chain next couple of days for the attendees here.
And maybe just quickly how this whole design process, we just get involved in the pre-construction stages very early. In about 10 weeks, working with your local engineering company, we can come up with a probably building permit set that's up to 90% completion. And then from there on, obviously, we go into the building permit stage. When that is approved, about 8 weeks from there, we can be on a job site with the first batch of material to start erection. And obviously, the schedule that we provided earlier will be starting from that point on. On every site, we also use the pool planning. I just want to kind of quickly go over that. We work with the local general contractors or whoever is in charge of construction, whether it's a CM or general contractor. We use LPS and pool planning on every job site. We're fully equipped to do that on every job, and this saves, again, it gives a visibility to entire construction sequencing, and also saves a lot of time and ensures that delays do not happen.
Sorry, Slobodan, I just want to make sure, in the interest of time, we get to the costing discussion.
Sure.
Just before we run out of time. Maybe walk us through, I know every project is different, depending on the logistics, depending on timeline, depending on complexities. There are different things that will kick in when you price a job. But maybe just give us an order of magnitude comparison between CIP, cast in place concrete, on one end, and then the other end being the stick frame let's put it up by 2 by 4s.
So I'll skip to the case study that we've done recently. So we've done a case study with an independent agency, Stelligence. Basically, they hired an architect engineer on a project, on a hypothetical project where we literally had to design three different systems, and three different systems were priced. The reason why we did it this way is because we wanted to do the full LCA analysis for life cycle analysis for carbon and everything else with three different systems. So in this case study, you can see very quickly here that steel structure was about, it was a 6-story building, composite floor with the light gauge steel walls versus cast in place versus heavy timber. And when I say heavy timber, this is not a stick frame. This is like a
Panelized wall.
panelized walls and a heavy timber. So basically a CLT. That's the word
CLTs. Okay.
that's the word I was looking for. So as you can see, that steel came the most favorable one. The project was in Hamilton. Steel was about 16 million. Concrete was about $1.5 million more, and CLT panels were even more, about 19 point something million. So you can see that concrete was about 10% more, and a CLT was about 20% more. Also, there was a month and a half schedule saving between concrete, let's say, and steel. And if you look at basically all the carbon emissions and a full LC analysis below, pretty much steel beats concrete and CLT in any instance. The only time where we're almost equal to CLT is on a carbon emission itself, CO2 emissions. But all other instances in this study, actually steel came most favorable one. So we have this study. This is a public study. We can share this with the audience as well.
And I think that's an important point to make, that like we have this whole thing going on with mass timber. I'm fortunate enough to be working on a couple of mass timber projects, and it's a very good thing that is happening. But at the same time, it's not like mass timber is the cleanest and everything else is just non-clean or dirty or bad for the environment. There are spectrums of things you can do, the options you can mix, and even hybrids. Even for concrete, there are
Yes.
improvements that are happening. But yes, it's good to know where we are. And in the next 3 minutes, can I ask you to let us know what you think of this whole tariff situation? Hypothetically, if you're a builder developer in Canada right now and you have a CFS building that is using Canam or other suppliers in Canada's products, what do you think is the immediate effect of this thing that's going on?
Well, we believe, obviously nobody has a crystal ball. Nobody knows exactly what's going to happen, but we believe that those tariffs and the way how they're put are different from the ones in 2018. If you remember, first Trump term, reason why we say it's different is because at that time was kind of a more for negotiation. Right now it's a tactic. Now it looks like it's a little bit more permanent. But in any case, all our steel, we're a Canadian company. All our steel on the Canadian side is sourced from the Canadian steel sources. Only some jumbo column sizes and beam sizes are solicited from the US or abroad. It can be done from Japan, from Europe, or other places. We're able to get the steel from basically from Canada or offshore without going through the US. So all our steel is sourced not through US. So from that perspective, we don't believe that's going to impact the material cost increases. And I heard from one of our largest steel mills in Canada, without naming the names, they said, look, if the market goes down, which it might in Canada, that actually steel prices could even go down because the demand will go down quite a bit. So we don't see that prices are going to shoot up. Again, nobody knows, but we don't think it will. We think that the prices are going to be fairly manageable from that perspective. But if anybody's exporting to US, that's the part that's going to be affected more or less.
Perfect. And that's one of the good things about this whole situation, is that we have the raw material in Canada and the capacity to be producing these things. And hopefully that doesn't significantly affect our housing crisis solution. A lot of time is up. I'm more than happy to stick around with you, Slobodan, and go through. But we want to thank anyone who has to jump off at 1 o'clock. For those of you who want to Stick around. By all means, ask us the questions. We're going to be here for the next 15 minutes to answer any questions you might have. I don't know if Slobodan, if you have anything else that you still want to present. Maybe we finish your slides and then go back to questions.
Yeah, basically, there's a few other, cost studies that we've done. This is one that we've done ourselves on a cost-in-place building in Ottawa, actually, where and this was done just prior to COVID, so the numbers really are a bit off per square foot when you look at them. But even today, the ratios are usually the same. But the one that I can point out to is you can see that this was a care facility originally designed with concrete. We flipped it to steel. We saved 10 weeks in a schedule. So that was a huge cost saving just there. And also the system was outperforming in terms of cost, the concrete structure as well. And maybe next one to show you the wood, stick frame wood that was done actually recently. Project in Edmonton, originally designed stick frame wood. We switched it to light gauge steel and Hambro, where we compared literally apple to apple costs from cost of foundation to cost of envelope to basically hard cost of construction itself. And we came up that the stick frame wood is only 8% in apple to apple, because I can tell anybody all the time, you will never beat wood. Wood is wood, stick frame wood. But in this case study, we showed that we were only 8% apple to apple more expensive, but you're getting incomparably different quality of a building, right? So, and also appraisal value on top of that 8%. Appraisal value on a steel building is about 3 million more on the same building than with wood. So they immediately after construction is finished, they gain that actually difference in appraisal value. So,
And I want to interrupt you there for a second, because I want to second that thought that I don't think you can on a small building, and I see this coming in the questions right now as well. On a small building, 3 stories, maybe even 4 stories, it's really, really hard to beat the stick
yes,
framing cost. And that goes back to the question that we started this presentation with, and that's the upfront cost versus the overall cost. Like you said, there's an overall benefit in not using wood for your performa. But one thing that I want to emphasize, at least in my personal experience, is that when you go with stick frame wood in a multi-family, multi-floor unit situation like the one that is on the screen right now, you will run into significantly more challenges, or you have to be very good at what you're doing to try and figure out all your flanking details, rating detail, acoustic rating, fire rating, and also sequencing on the job site, making sure everything stays watertight. I definitely do not want to rule out stick framing for the high, low rise section. There's definitely a place for it, but it's good to know when you're going in that if you're going to pay, let's say hypothetically on 10,000 square feet, you're paying $200,000 less when you do wood compared to CFS. It comes back in other places, so you need to look at the overall picture. Sorry to interrupt you there.
yeah, no, and like you said, it has to be looked holistically, overall, apple to apple, including everything. For example, when you compare to cast in place concrete, a lot of people don't think our structure is a half of the weight of the cast in place concrete structure. So if you have a bad soil, your foundation on a cast in place building can be tremendously bigger because we're 50% of the weight. We only have a 3.5, 4 inch slab versus 8 to 10 inch slabs, right? So there's a lot of these things that we can point out, and we have a multitude of studies that we can show. It doesn't work always, not always, like you said, not every project is suitable for our system, but it has to be thought of early enough, and it has to be designed around the system in order to take the full advantage of the system.
Perfect. Do you have any more slides left? Or
No, I
we
think that's
are almost,
basically it.
that's basically it. Okay. We want to just turn it to the audience. If there are any questions here, the slides will be downloadable. We're going to send you in the next 48 hours. Probably you're going to get an email with the link to the slides and the presentation itself, this with the video recording that we have right now.
And I'll also
Just going,
send a portfolio of projects that we've done in those recent years across Canada, especially in Ontario. It's divided per province, so they can see, audience can see basically what we've done around. Like I said, we've done millions of square feet in the last few years all across Canada.
perfect. Thank you very much. I think we answered all the questions. I don't see anything else coming in. I thank you for your time. Thank you for sharing these slides with us. And thank you for our audience. If you enjoyed this, please make sure you visit our website. We have more content, podcast content, and also other items that relate to the same topic. If you know of any systems or any products that can help us in our mission trying to build more mid-rise buildings, please feel free to email us and share with us. And we go from there. Hopefully, we see you
And
guys
Pam,
soon.
are you gonna provide them with the emails, our contacts, just in case if they
It
have
will
more
be.
questions? Okay.
If you want to spell it out, please do. It's not on the screen, but I will also include it in the email chain that will go out later.
Yeah, perfect. If you guys have any other additional questions or requests, we're more than happy to give you a hand.
Thank you, everyone. Have a great day.
Thank you.